Hello guys, welcome to my next class of single random variable that comes in 18 EC 44 means 44. Yeah, we discussed in all my previous videos all theory part for the single random variables. Now we are going to take some problem based on that. First problem is an information source generates symbols at random from a four-letter alphabets A, B, C, D with the probabilities P of A is equal to 1 by 2, P of B is equal to 1 by 4, P of C is equal to 1, and also P of D. Both C and D are must be 1 by 8. According scheme encodes these symbols into binary codes as follows. A is 0, B is 10, C is 110, D is all are 1. Okay. Now, uh, let X be the random variable. X be the what actually? X be the random variable denoting the length of the code. They given already what is X stands for. Let X be the random variable denoting the length of the code, that is number of binary symbols. Number of binary symbols are bits. Now based on that, sketch the CDF, cumulative distribution function, means fx of x of x, and specify the type of x, and also find probability of x less than or equal to 1, probability of x greater than 1, less than or equal to 2, and probability of x greater than 1, and also probability of x greater than or equal to 1, less than or equal to 2. Yeah. From this, in this problem, first show, if you want to sketch or if you want to do, to write the graphical representation, means first you have to know what is fx of x from the given probability. What is x denotes? Let x be the random variable denoting the length of the code, means the number of binary symbols are binary bits. Now fx of x from the definition of cumulative distribution function, first you have to convert cumulative in terms of probability. What's the probability formula? Probability of x less than or equal to x. Now probability of x less than or equal to x, you know that there are probability of what about P of A is 1 by 2, P of B is 1 by 4, P of C and P of D is equal to 1 by 8, and also a coding scheme encodes these symbols into binary code as follows. A is 0, B is 10, and C is 110, and D is 111. Okay. Now based on that, we are going to write what is my value. See, what is x denotes? X denotes the number of binary symbols. The number of binary symbols are bits. Suppose x less than 1, what's the value is nothing but 0, because no, there is no value. The number of binary symbol or bits is 1. Okay. Next, 1 to 2 means from 1 up to less than 1 is 0. You given based on the probability. P of A is 1 by 2, P of B is 1 by 4, P of C and P of D is 1 by 8. And based on that, they convert into the binary codes for A, B, C, D. Now based on that, up to the less than 1, what's the value of the x? What is x actually? Is denoting a binary bits, number of binary bits. What is that? Probability value is 0, because there is not there the probability value, therefore this is 0. X start from x is equal to 1. Please try to understand, it's a discrete, means you have to include, exclude for the value also depends. X here 1 is not included, but here 1 is included. X is start from 1 until less than 2. What's the probability here is means is start from what about that number of binary symbols are start from 1 up to less than 2. What's the probability? P of A probability is 1 by 2. Therefore, sum half plus 0 is half only. Are you clear? The next step is start from number of binary bits is equal to 2 until less than 3. Until less than 3 means what's the until less than 3, what's the probability have? 1 by 4. Okay, until less than 3. Start from 1 less than 2, this is 1 by 2. Take the sum of that, because cumulative probability means take the sum of the previous value. 0 plus half is half. But now to start from 2 until less than number of binary bits is less than 3, what is that? C. What is P? Up to C? Up to C means this value 0 plus 1 by 2 plus what about b value plus b is what 1 by 4. What we get was 0 plus half plus 1 by 4 is 3 by 4. Because cumulative distribution will take a sum of previous all the probabilities until reach that. Please try to understand x greater than or equal to means equal to 2 by number of binary bits until less than 3 up to this. Up to this means 1 by 4 means 0 plus half plus 1 by 4 3 by 4. The next is greater than or equal to 3. Greater than or equal to 3 means x is equal to 3. After the 3 means greater than or equal to 3 means what actually? The minimum value of number of binary bits is 3. Minimum value of binary bits 3 until it goes infinitely. Now here minimum is 3. Now what's the value have here? That values they given here 1 by 8, but they given P of C, P of D is 1 by 8. Now is what is 3 by 4 plus 1 by what about that 1 by 4. I'll take half of that because the half of that P of C is 1 by 4, this is 1 by 4, then 1 by 8, then half of that is 1 by 4. Now please try to understand that how we get 1 by 4 here. 3 by 4 plus 1 by 4, what is sum must be equal to 1. Then this is a way to find out. You see, observe carefully here. What is a 3 until 3? The minimum is 3 in number of binary bits, and greater than or equal to number of bits is 3 is what about that value is 1 by 4. 3 by 4 plus 1 by 4, what we get actually. I have to add these two, P of C and P of D. This is 1 by 2. Now I make it as add, we get 2 by 8. 2 by 2 by 8 is 1 by 4. We added 3 by 4 plus 1 by 4 is we get 1. This is a way to find out cumulative what about distribution value based on the binary codes, binary bits, binary symbols. Compared to me, you clearly understood how we get this. Okay, after that you plot a graph. I told while writing a graph for the cumulative distribution function, we get just a histogram. Therefore, now observe up to less than 1, what's the value? 0. Up to less than 1. Start from equal to 1, equal to 1, up to less than 2, what is that? Half. Yes. 2 to less than 3 is what? 3 by 4. And then after 3, from 3 onwards, what is that value is 1. This is a way to write the sketch or graphical representation of corresponding cumulative distribution function. Okay, next I want to find out probability of x less than or equal to 1. This is a point, this is one of the question they are asking, probability of x less than 1. Probability of x less than or equal to 1, you know how to express in terms of cumulative. That exactly equal to cumulative function of capital X of 1. You have cumulative function value, and therefore once you express in cumulative, then easy to find out. That's why what we did here, instead of expressing a probability, better I to express this in terms of cumulative function because you already have that. Okay, fx of 1. Fx of 1 means this is value from 1 to less than 2. Therefore, what is fx of 1 is half. Then probability of x greater than 1 less than or equal to 2. See, probability of x greater than 1 less than or equal to 2 is nothing but fx of 2 minus fx of 1. Fx of 2 is nothing but actually you already know that fx of 2 means start from 2 means 3 by 4. Fx of 1 means half 3 by 4 minus half we get 1 by 4. In the next step, we are going to find out what is the probability of x greater than or equal to 1, x greater than 1. You know that already x less than or equal to 1. Better I to write probability of x greater than can be written as 1 minus probability of x less than or equal to 1. Here equality is not included, therefore I have to write equality. While finding a probability in discrete, please take care. Equality have a sense because you have a probability for each and every values of the random variable. But in continuous, suppose included equality or not included doesn't matter because point does not enclose any area in the continuous. Continuous is nothing but giving a area of that curve. Okay. 1 minus probability of x less than or equal to 1, because here equality is not there. You already know that value is half. 1 minus half is 1 by 2. Probability of x greater than or equal to 1 less than or equal to 2. Please try to understand probability of x greater than 1 less than or equal to 2. What you written, f of x, fx of 2 minus fx of 1. Here 1 is not included. Therefore, this can also be written as probability of x greater than or equal to 1 less than or equal to 2 can also be written as probability of x is equal to 1 plus probability of x greater than 1 less than or equal to 2. Right? X is equal to 1, probability x greater than 1 less than or equal to 2. Both this is must be same because it's a discrete. That's why I told they have a sense for each and every value. Then you have probability of x is equal to 1. Probability of x is equal to 1 means what actually? Then number of binary symbols is 1. Number of binary symbol is 1 means B. Probability of B, what they given is, what about that number of probability of x is equal to 1. Probability of x is equal to 1, what we have actually, x is equal to 1 is 1 by 2. Observe this, x is equal to 1 by 2 plus probability of x greater than 1 less than or equal to 2. Now what we get actually 1 by 2 plus this value already calculated minus 1 by 4 we get actually 3 by 4. I think is clear everyone how we get this value. 1 by 2 plus 1 by 4 is nothing but 3 by 4. Please try to understand greater than or equal to 1 less than or equal to 2 can be written as x is equal to 1 and x greater than 1 and less than or equal to 2. Now this is a way to find out the value of the function because probability of x is equal to 1 means now I am going to use the value for p of a is equal to half. Yeah, they given probability value half. Then substitute and simplify. I think is clear everyone. Similar type problem, please refer any textbook and then you work it out. I can't take more problem to discuss in my video classes. Okay. Now I'm moving to the next problem for continuous. This is we discussed what I taken much time to explain because my aim is the students must be understand the concept, then easy to solve the rest of the problems. Okay, let x be a continuous random variable x with the probability probability distribution function. What's the probability? This is actually PDF, means they are having unknown probability density function. Probability density function is nothing but fx of x is equal to kx for x lies between 0 to 1, 0 otherwise, where k is a constant. Determine the value of k and sketch fx of x, means sketch corresponding PDF. Find and sketch the corresponding CDF, means cumulative distribution function, capital Fx of x, and also find probability of x greater than 1 by 4 less than or equal to 2. Observe this is a problem in which one continuous. Okay. From the properties, because they are not given any, just like previous problem, they given P of A, P of B, P of C, P of D value. They given each and every possibility values, the what is the for x value, they given corresponding probabilities. But here they define in the range for x 0 to 1, this is a probability. In other case, this 0 like that, therefore it's a continuous. Now they given already in the problem, the given problem is a PDF. PDF means what actually? Probability density function. When we will say that in continuous is a probability density function, the given probability function is greater than or equal to 0 and also integration of minus infinity to plus infinity fx of x with respect to x is equal to 1. Therefore, they given already in the problem is a PDF. Therefore, from the properties of PDF, I am going to take second property minus infinity to plus infinity fx of x is equal to 1. Then now based on the given probability function, I am going to change the limit is 0 to 1 because except 0 to 1 in rest of the case the function is 0. Therefore 0 to 1, what's a function you have? Kx with respect to x is equal to 1. And then integrate it. K is a constant, keep it outside. What is integration of x with respect to x is x square by 2. K by 2 is a constant. Apply upper and lower limit. We get k by 2 equal to 1. That implies what's the value of k is 2 only. Now I have to substitute k is equal to 2 in fx of x. We get 2x for x lies between 0 to 1 and then 0 otherwise. From this, I want to find, I am going to do the sketch together for probably PDF and also CDF. Okay, first you have to find out CDF from the PDF. Yeah, from the definition of cumulative density distribution function, this can be written as probability of capital X less than or equal to small x. Therefore, that nothing but minus infinity to x because start from minus up to x fx of x. Now we can't substitute the value because they given a function only 0, no, what about 0 to 1. Therefore, I have to give a split minus infinity to 0, 0 to x. Minus infinity 0 from the given function, what is that given function value must be 0. Otherwise is 0. Therefore, only remaining 0 to 1. But I want to find out cumulative distribution function. I'll keep in terms of x only 0 to x, but given for the condition for x, what's the condition of x? X greater than 0, less than 1. Then only I'm going to substitute what is my fx of x is 2x. Are you clear? Yeah. Yes, and then integrate, simplify that, we get x square. This is x square. What's the condition for x? X must be less than 0 to 1. And then fx of x, fx of 0 I want to find out. What is fx of 0? Probability of x less than or equal to 0. Probability of x less than or equal to 0. What happened? Minus infinity 0. Up to this, only have a function here 0 to 1. In rest of the case, what's a function here? 0 only. Therefore, this integral value must be 0. Therefore, now I have to find out probability, the fx of 1. What is fx of 1? Means probability of x less than or equal to 1. Means minus infinity to 1 fx of x. Minus infinity of 1 can also be written as minus infinity to 0, 0 to 1. But minus infinity to 0 is 0, 0 to 1 is 2x. Integrate and simplify that, we get 1. Now I'm going to write based on that what is my cumulative function. What is my cumulative function? Is 0 for x less than up to less than 0. X square is from 0 to 1. X greater than or equal to 1, what is my fx of x is 1. Just now we calculated fx after 1 for all values of x, cumulative distribution value must be 1. This is a way to find out cumulative distribution. You see, you feel madam is included equality here. If you want added this equality here, doesn't matter. Here also we get 0, here also we get 0 for x is 0. Okay, don't worry about that. Then you plot a graph. First we have to plot a graph for what actually PDF. X versus to f of x. You know what is fx of x. This is my f of x. What is my f of x is 2x for what about that 0 to 1 and 0 otherwise. Therefore 2x is vary from 0 to 1. Therefore up to 1 less than 1. What's a function? We get a line, right? We get a line less than 1. Less than 1 means up to 2. Less than 1 means up to 2. Yeah, up to 2. After 2, yes. What we get here in other cases 0. Therefore, it goes on like that. Okay. Next is, I want to write a graph for which one? Cumulative distribution function. In the cumulative distribution function, please observe carefully here. In the cumulative distribution function, what we have? Actually 0 up to less than 0 or equal to 0. X square, we get a parabola. X square from 0 to 1. That's why it's a parabola. Okay. Then after x, start from x is equal to 1, then goes on line, horizontal line parallel to the x-axis. Therefore, this is a parabola because x square. This is a way to plot a graph or sketch for given PDF and CDF. I think it's clear. This is for the example for continuous. Next, I'm moving to the another one thing I want to find out. What's another value? I want to find out probability of x greater than 1 by 4, less than or equal to 1 by 2. The probability of x greater than 1 by 4, less than or equal to 2. Keep in mind in continuous either equality is there or not included or not included does not matter. Continuous means we are doing integration. Integration gives us area. Therefore, suppose we have to choose any point on xy plane, point does not enclose any area. Suppose if strictly greater than also is possible to write equality. That is thing you already know that in probability classes in module 3 and module 5, where in the 18 mat 4.1. Okay, from the cumulative, why? Because you have a cumulative function fx of 2 minus fx of 1 by 4. See, in fx of 2, Fx of 2 means after 1 itself is nothing but after 1 is 1. Fx of 1 by 4 means I have to take x square. X square is 1 by 4. 1 by 4 is 1 by 16. Therefore, 1 minus 1 by 16. 1 minus 1 by 16 is what actually? 515 by 16. This is a way I have to find out the value. Okay, now moving to the next problem. See, I told in the previous video some function I'm not even sure that probability function is PDF. Therefore, I consider most of the problem in this problem. I verified whether probability function for exponential, normal, and also normal we already done, exponential, and then what about that uniform distribution, and further problem I discuss. Okay, show that similarly show that probability function of a normal distribution is a PDF. This part we are not discuss. I told in the previous video all probability function we are going to verify in the problem whether it is a PDF or not. In the examination they are going to ask the question, define normal distribution and verify that it is a PDF. See, this is our probability function for normal distribution, 1 by 2 into root of 2 pi e power of minus half of x minus mu by sigma whole square, x range between minus infinity to plus infinity. Clearly for this sigma you already know that standard deviation must be positive. Therefore, fx of x is clearly greater than or equal to 0. Next I have to verify second condition. Therefore, I consider minus infinity to plus infinity fx of x with respect to x is nothing but I had to substitute the function. You already discussed in my previous video, we had to convert this integral must be which form e power of minus x square minus infinity to plus infinity because that value is root pi. Therefore, I will go for substitution x minus mu by sigma is t and then simplify that x is equal to mu plus sigma t. Find change x to dt. Then you substitute here. Why I am doing a little bit fast because you already know that this point we discussed clearly in the last few videos. We get e power of minus half of t square. What is dx is sigma dt. Limit must be same. Again I have to skip this 2 because only I required quotient of t square minus 1 t by root 2 whole square. Therefore put t by root 2 is u and then simplify that. We get minus infinity to plus infinity e power of mu minus u square root 2 cancel. What about this value is 1? Therefore then we say that the probability function for normal distribution is a PDF. Yeah. I thank you very much for listening for this. I'll come and meet you next further few more problems in next video. Okay, thank you.